So after the addition rule, the subtraction rule is really just a little tweak on addition. And here's how it goes. A minus B is the same thing as A add the opposite of B. So we already did that. We just finished that with addition rules. So anytime we have an addition problem, we can switch it to an addition problem where we're adding the opposite of whatever the original subtracted number was. So an example would be 14 minus 8. But that's just the same thing as 14 add the opposite of 8. And on the number line, there are two ways to look at it. Let's make a nicer number line. The first is what we've already been doing. If you start at 14 and it's addition, so you're going to head in the right-hand direction, but minus says to add the opposite direction. So I'm going to add in the opposite direction. 8 bounces backward. I'm not sure how many that was. 1, 2, 3, 4, 5, 6, 7, 8. Oh, you did it. So what would that be? It'd be the same thing as 14 take away 8, which is 6. Okay, so my units here don't necessarily look as great as they could. I'm a lot closer to 0 than I think I would be, but on the number line, it's just a visual model for working with addition and subtraction. So let's do a different number line, only use the first form, the 14 take away 8. You'll see that I'm going to do exactly the same thing. I start at 14, and I'm always going to be wanted to head in the right direction before I get my next instruction. My next instruction, I started at 14, the next instruction says turn around. I do. Bounce 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And that puts me at 6. So I get the same answer no matter how I look at it. In one way, I have a plus sign, and so I'm headed in the right direction because I'm obviously dealing with addition. And the other way, I'm noticing that every time I find my position on the number line, I assume I'm going to do addition, and then I only turn around backward if my numbers or my symbols tell me to. So let's do a couple of examples. I think that's the easiest way to see all of this. Example 1, negative 18 minus 3. So where would I be? Well, let's make a number line. And the first number I'm at, or where I'm going to start, is at negative 18. And I should always just automatically assume I'm headed in the right direction. So after negative 18, I have a turnaround instruction, and then bounce 3 times. 1, 2, 3. So where would I be? 18, 19, 20, 21. I'd be at negative 21, so that equals negative 21. So example 2. Negative 9, oh, there are a bunch of minuses on this one. Negative 9 minus 12. Holy Toledo. All right, well, that's easy enough. So I either draw or visualize that I start at negative 9 because that's the first number I'm dealing with. Always assume you're going to get to go in the right direction, but a negative says to turn around, and another negative says to turn around again, and now I have a number that tells me how many times to bounce. Now, rather than bouncing 12 times, I like to do a loop to get to 0. I'm obviously going to go past 0 if I bounce 12 times, so I'm going to count 9, 10, 11, 12 to see where I am. See what I did? I just one swoop to get me to 0 rather than trying to pace out my little wiggles to get to 0. Just 9 of them gets me to 0, and 3 more gets me to 3. So this would be a really good time to formalize something that we did here where we have all these turnarounds going on. Let's notice. If I have 2 minus 3, then on the number line my instruction says I'm at 2, headed the right direction, right? That's where I am to begin with. Minus says turn around one time. Another minus says turn around another time. So that's two turnarounds. Well, if I turn completely around once and then turn completely around again, I'm just exactly where I started. And since where I started was going in the plus direction, two minuses together equals a plus. I can just make that assumption. So in this case, I would work this problem by saying 2 minus negative 3 is the same thing as 2 plus 3. So that equals 5. And let's confirm that on the number line. I started at 2, going the right direction. The first minus says to turn around. The second minus says to turn around again. And now I'm going to bump 3 times. 1, 2, 3. Well, where am I? 2, 3, 4, 5. I'm at positive 5. So what if there's more than 2 minuses? So what if I'm looking at something like 6 minus 4, whoop, that's not what I meant to do, minus 3. How about that? 6 minus 3. Certainly not something you like to look at, but something that can come up all the time in algebra. So let's just figure it out on the number line to begin with. So we're going to start at 6. Always assume you're going in the right direction. And then you come to a minus, which says turn around. You come to another minus, which says turn around. So 2 minuses, we already know from this other example, means that you're at plus again. And then I do have to turn around again because there's another minus. And this time when I bounce 3, I end up at 3. So we can kind of generalize a rule from this. We can notice that if there are 2 minuses in a row, they become a plus. Right? So minus minus right in a row without a number in between. If there's a number in between, it's not the same thing as minus minus. But 2 minus signs right in a row, you can turn them into pluses. And you can see I did that here. I just turned them into pluses. So I had 2 pluses instead of 2 minuses. We say in math or in arithmetic that 2 negatives make a positive. Okay, so let's apply this to some more examples. Suppose I have negative 3 minus negative 6. Well, that would be, there's only one negative with the 3, so I have to keep it. And then minus minus means plus 6. So now I've just converted it to an addition problem. I start at negative 3, and I'm going to go in the right direction. I'm going to go 6 bounces. So 3, 4, 5, 6 puts me at a positive 3. Okay, so let's do another. How about negative, or the opposite of 8 plus the opposite of 4? Okay, what does that do? Well, minus minus right in a row, minus minus, those can be pluses, so that becomes a positive 8 plus a negative 4. So on the number line, or using the math rule, we can say in reverse, we know that 8 plus negative 4, let me come up here where we started, right here, something plus negative something is the same thing as just subtracting that. So a plus minus becomes 8 minus 4, and so this answer is 4. So if you have to do this one on the number line, and for a little while you'll have to do it both ways, you have, let's see, where did we start? I started here. Well, look at this. This is kind of hard to see, isn't it, with the minus minus? But I know I'm starting at 8. I have the number 8, which says I'm at 8, but I'm really at the opposite of 8, which is negative 8. But I'm really at the opposite of negative 8, which is a positive 8. So all of this together is a positive 8. plus, so I'm at positive 8, headed the right direction. Minus says to turn around and bounce 4 times. 1, 2, 3, 4. And so I'm at 4. So let's expand this rule and put it into symbols rather than words, because it's so much easier to deal in symbols. If I have two negatives, excuse me, that's not how I meant that. If I have a minus, minus, two negatives side by side becomes a plus. If I have a minus and inside is a positive, that's going to stay negative. And if I have a plus outside or just a negative inside, a parenthesis, that's going to stay a negative. So whenever I have a positive and a negative, it becomes a minus. But whenever I have two negatives, it becomes a plus. And the rule we don't really have to write down is that a plus and a plus, that's always going to be positive. Positives are always positive. But if you have the same sign, side by side, not with a number in between. If there's a number in between, it's a whole nother ball of wax. But if you have minus, minus right in a row, you can convert that to a plus.